Hello, and welcome to today's webinar, Running PeopleSoft on AWS Using Infrastructure as Code. My name is Kim Stewart, and I will be the moderator for today's event. As we go through the webinar, if you have questions for our team, please type those into the chat on the left side of your screen. We will be responding to all questions via email. I would like to introduce our presenter, Tim Rogers, who is the Director of Cloud Technology Solutions for Sierra-Cedar. Tim, thank you for joining us, and I will turn the presentation over to you.
Great, thank you, Kim. So today we're going to talk about infrastructure as code. I want to introduce you to some of the key concepts there, give you some things to think about along the way. We're not going to go deep into infrastructure as code, but just touch on some of those key elements, and then we'll touch on the benefits of infrastructure as code and how Sierra-Cedar is using infrastructure as code today. So when we talk about new concepts, I like to start out with a definition, and then also for clarity, infrastructure as code is really closely aligned with efficiently deploying and managing cloud infrastructure, rather than a traditional data center approach where you would be physically installing and racking server hardware in a data center. So what is infrastructure as code? Well, Wikipedia provides us with a pretty good definition. It states that infrastructure as code is the process of managing and provisioning data center infrastructure through machine-readable definition files rather than physical hardware configuration or interactive configuration tools. So in a nutshell, instead of physically placing server hardware in racks and manually configuring the servers and cabling them up and whatnot, you're essentially treating your cloud infrastructure that you'll be running your software applications on as software itself. So infrastructure as code is a really big shift from the traditional data center thinking, and is often compared to the changes that have occurred over time to automate common tasks within a factory. So let's talk a little bit about a couple of different ways that you can build out cloud infrastructure. So almost everybody will follow the natural progression of starting out with a simple or gradual process, and using the AWS console is a great place to start, right? It's also where you are initially going to be setting up your cloud accounts. So it provides for a guided configuration wizard to take you through each step of the process as you build out your infrastructure. And as you're doing that, you're taking your time doing it. You're also developing a good understanding of how you're configuring those cloud services. But one of the drawbacks is that you're kind of limited on scalability. So building out 2-3 servers manually through the console, probably not a big deal. But when you've got to scale up to say do 20 or 50 or even 100 servers, it can be a pretty burdensome task. And since you're doing it all manually through the console, there is some element of human error that may creep into that. So as you gain the experience, right, you're going to be looking for a more efficient way of doing it, and taking a look at the command line interface. The CLI is a great place to migrate to, right? You're able to start scripting out some basic tasks. You might be using the command line interface to stop and start servers or some other basic tasks. But at this point, you're able to do things in a more scripted fashion without having to access the wizard or the point and click approach that you do through the console. However, you still have some limitations. You don't have a great view of the current state of your overall infrastructure, and while you are creating scripts, you're still managing all those scripts manually, right? Which, again, error prone, and some challenges there. So the other approach is the application programming interface, right? This is where things really start to happen, right? You have fine-grained control of your resources, and you're also able to start to leverage some of the automation tools and platforms that are out there that we'll talk about here in a bit. But some of the challenges are it's not easy, right? You don't have the wizards to guide you through the process, i.e. no training wheels. And it requires experienced developers with solid understanding of development processes to deploy and manage your code. So, with, as I mentioned, you've got, a lot of options to choose from a tool set, right? So you can actually start leveraging some of these tools and platforms. But, got to keep in mind that a lot of these tools that are out there were developed or originally designed from a traditional data center. So, their usage is really focused on an imperative approach or a step-by-step scripting approach, which is not necessarily the most efficient for an infrastructure as cloud approach. But there are other tools out there that were created with the cloud in mind and tend to be more of a declarative approach, which means you really define the end state that you're trying to achieve and not, not the step-by-step process on how to get there. So in the previous slide, I introduced the concept of an imperative approach. So basically, it's an approach where you specify a set of step-by-step instructions that need to be followed to achieve a specific end result, right? The imperative automation approach originated in the data center, as I mentioned before. But it was it was a good fit because data centers typically weren't standardized. You've got different server types, you've got different operating systems, storage needs, and so on and so forth. All having different levels of automation need, and therefore you've got to have highly customized and specific processes. So in the example that I've got here, right, it's just making a cup of coffee. It's going to have a very specific end result. You're going to grind the coffee beans with a specific texture. You're going to add coffee to the basket, heat water to a specific temperature. You're going to pour over the coffee. It's going to drain, et cetera, right? You've got total control over the process, and it works, right? So, but what happens when, something, is already done for you, right? I mean, maybe the coffee's already ground or, the coffee is already heated, right? That's when things start to, to be, a challenge, right? And you've got some rework that needs to be done. So an imperative approach works when you have a guaranteed start state and you know what the end state is that you want to get to, right? Typical of a traditional data center. So a declarative approach, right, which I briefly mentioned before, and a declarative approach, it's going to be more. This is more of what the cloud environments are looking for and more typical there. So you're focused more on the desired state or the what, and not necessarily the minutia of making it happen, right? That's what's left for the tool or the platform that you're using in order to get you there. So in a declarative process, in this example, right, the process for making coffee, it's really already socially defined, so there's no need to define it. You really only need to define the basic inputs, whether it's a dark roast, a light roast, number of sugars, and so on and so forth. The code that you create defines the state, not the process. There are some drawbacks though, and that is if you've got highly customized or complex tasks, a declarative process may have some problems with that. So in that case, an imperative approach might make more sense, to be able to get to your end state. But ultimately, your goal is convergence, so that you can get to where you need to. So on the convergence, right, convergence ensures that only the changes that need to be made to the code are executed. So as you move from version 1 of the coffee to version 2 of the coffee, right? Where you maybe you're just adding cream. The only change that needs to be added to your code line is to add the cream. So with an imperative approach, the developer is relied upon to do all the planning and ensure that all the steps are correct to achieve the desired end state. And with a declarative approach, you're leveraging the tool to create the plan. So you're actually focused on what you want the end state to be, and the tool is helping you to get there and figuring out how to get you there. In most cases in the cloud, you're going to be wanting to focus on a declarative approach where possible. But like I said before, it's possible that you may need to use an imperative approach for some of those highly complex tasks that need a more defined approach. So I talked about tools. So this really is just kind of a representative example of some of the tools that are out there. The automation platforms that are there are really there to assist you in working as efficiently as possible. So, Terraform is a pretty popular platform. It's more of a declarative platform and is a multi-cloud tool. So you can use it across multiple different cloud vendors. AWS CloudFormation, which is also a declarative platform. That's a specific tool. That's AWS's, automation platform tool specific to AWS. Other tools that you might be familiar with are Chef and Ansible. These tools are tools that encourage more of an imperative approach. So it is possible that as you go down the path, you may be using multiple different tools to achieve the end result, right? Which could be a combination of some declarative and some imperative. It just kind of depends on what your needs are. Okay. So as part of your journey to get to an infrastructure as cloud mindset, you need to look at realigning your teams, right? So, traditionally you've aligned your teams to a technology stack, like a Linux, Windows, network, storage. But really with a cloud infrastructure as code mindset, you really need to be looking at aligning your teams toward business goals. And those goals tend to span the whole stack. So, you're going to be building a cloud architecture, right? That's a business goal. It requires the use of these technology stacks, the whole stack, right? It needs to be architected, needs to be secured. You need to automate it, to the delivery of the architecture itself. You've got to monitor it, and then you've got to support it. So I'll talk about how all these kind of work together on this slide here. So your teams, you're going to be aligned into 3 main functions, right? We talked about architecture, development, and operations. But it's critical that these teams work together, right? Your architecture team is going to be setting up the guidelines for the business. What is or isn't allowed to be changed. They're going to be, designing firewall rules and deployment locations and things like that. Your development team is going to translate the specs or the design that the architecture team creates into a usable code, and that code then is going to be consumed by operations. So operations is going to be managing and planning the deployment of the infrastructure, leveraging those things that the development team has created for them. And then each team is critical to the process, right? So, the feedback loop that occurs within each, they all kind of touch in the middle at some point, right? So you could have feedback and identifying bugs, enhancements, or even new features, really from any of those teams, right? And that's going to be critical to the continuous enhancement of your infrastructure and continued evolution of your infrastructure. Okay. So as you move forward with a code mindset, right? You need to stop thinking about your infrastructure as servers and start thinking about them as software really, or as code. So if you have a development DevOps framework in place, for your application development, in most cases that those same tools and processes can be leveraged for your infrastructure teams as well, right? So you're not necessarily recreating the wheel. You're kind of building upon and or leveraging what you've already adopted or have done today. If you don't have a DevOps framework, you need to start thinking about adopting one, right? It's going to be critical to the ongoing evolution of your infrastructure in the cloud. You'll have to include planning and design, testing your code, source control, versioning, all those things that are really part of a DevOps, a typical DevOps framework. Other things to think about as you adopt an infrastructure as code mindset, is as you build your processes, build business process and standards into the code. If you build your processes into the code, it means you're going to, not have as much documentation to deal with. And, if you're updating it through your code, the update process is pretty straightforward. Other key things, like I said before, you're going to have a good source control process and or product to keep track of all the code changes, and as well as a history of the infrastructure changes through code versioning. Okay, so how does infrastructure as code benefit an organization? So I want to talk a little bit about the traditional data center, right? Some of the truths behind the traditional data center. In a traditional data center, you have a number of different siloed teams. You have Windows admins, Linux admins, network storage, etc. In AWS, these team roles typically move toward more of the business, identifying the business goals and span across the full stack. In a traditional data center, you lack cohesive endpoints. In AWS, the API allows everyone on the infrastructure team to interact with AWS in the same manner, using the same tools, the same rules, etc. You also have design trade-offs in the traditional data center, which are typically limited by hardware or isolation zones or lack thereof. In AWS, your design's not really limited by hardware or isolated deployment zones or failure zones, right? You pretty much can tap into the unlimited infrastructure that's there to achieve those goals. And last but not least, traditional data centers assume that humans will always do their work correctly, but no matter how well your processes are documented, humans are prone to mistakes over time. In AWS, you're leveraging your infrastructure as code processes that are designed to test the human developed code and then plan the changes and impacts to be put in place that greatly then, so you've tested those changes, and before you put them in place, you understand what the impact is and how they're going to work. So you're greatly reducing your impact there. So the key takeaways or benefits of infrastructure as code for any organization is that infrastructure as code reduces risk by eliminating error-prone manual processes and leveraging a code-based approach that's consistent, fully traceable, repeatable, and secure using a least privileged access approach. Delivery of infrastructure services are more consistent and predictable. Time to deploy is greatly reduced, and the impact of maintenance activities is also greatly reduced. Overall, the cost tends to be lower due to the infrastructure code reuse, efficiency gain through labor savings, through automating repetitive tasks. Okay. So while there are a lot of benefits to an infrastructure as code approach, there are a few things to consider. One, it requires work, right? It's not easy. You've got to have a development team that in place to follow, solid development processes to create the code and manage the code and version it and so on and so forth. You're also going to be mixing architecture roles with administrator roles, right? So, the provisioning of infrastructure will need to be isolated to the people that are designing it, right? So make sure you have a checks and balances in place, or a process of least privilege. Version control is critical, right? So as you deploy changes, if there's impacts, you might have to roll back, but version control will help you identify that, and it's part of a good change control process. And then, your path for legacy roles can be a change. Some of that, could be a reluctance to change within an organization. You're going to be able to operate in a more efficient manner, and some of those resources may need to be retrained and or redeployed to do other activities. So how is Sierra-Cedar using infrastructure as code? So, what we talked about today, is really just a small piece. So Sierra-Cedar has built a platform called FlexOps. It is our automation platform that we leverage in our managed services organization. And within the scope of things, the infrastructure deployment, you can kind of see the infrastructure diagram on the far right there, right? Those are all of the AWS services, or most of them anyway, that we're leveraging in building out of our PeopleSoft environments. And all of that is orchestrated through our platform to deploy the end state, whether it's a web server, app server, database server, or whatever, all through code. But there are other essential components, right, that you need to be aware of, and those include, versioning, change control, being able to detect configuration drift. So if a deployed configuration, drifts from a configuration that was originally deployed, you need to be able to be notified of those changes, so that you can then remediate that, and then automated infrastructure remediation. So in a nutshell, infrastructure as code, it's really complicated. But with all that said, going down this path will yield great benefits, and will help you, continue to evolve and develop your infrastructure for the future. So a little bit about Sierra-Cedar. We have a lot of ERP projects under our belt. We've got over 42 PeopleSoft environments in AWS running with our FlexOps platform, and we have over 125 AWS certifications. So we've got a lot of experience, and we're continuing to deploy into AWS. So Kim, I think that is about it.
Yes, thank you, Tim. If you want to move to the next slide. If anyone has questions that they did not enter into the chat, or if you would like to schedule an AWS technical assessment, please email us here at aws@sierracedar.com. Thank you again to everyone. We really appreciate you taking the time to join us today.